Okay, I'm glad to be here. The reputation of this creation group reverberates around the country. And you have I've heard about it many years since listening to Bob Inyard's radio programs where he often mentions it. And so you have a great deal of influence, and I'm very honored to be in a long line of leading creation speakers that have come to this creation group. So this is my story, an insider's view of Cassini. And we're going to talk about a lot of things, and I'm going to move fast because I have a lot of pretty pictures to share with you here. So let's get going. Like Rob said, I had a chance to work for 14 years on this mission. Do we have a laser pointer? You know, we don't really need it. I'll just point and you'll understand. But the spacecraft up there is huge. And there I am standing underneath a duplicate of it at the California Science Center. And I'm also very honored to be a special friend of Dr. Henry Richter, who is a bona fide rocket scientist. He is still living. He's 92 years old, but he was the manager of the instruments on Explorer 1, America's first successful satellite, January 31st, 1958. And he was at JPL. He's a JPL VIP, and he came looking for me at the lab when he was researching Explorer 1 to write a book on it, because he had read some of my ICR articles. And I didn't know who he was at the time, but I was blown away by this man's reputation. And so he's a great Christian. He's a young earth creationist. And I want to mention that I had the opportunity to work with him on his book. He had written a short self-published book, but I thought, wow, this is great stuff. It needs to be expanded and add some illustrations. So I worked with him for 2 years, and we came out with this book called Spacecraft Earth, A Guide for Passengers. And what I like about this book is that it not only shares a great deal of information of creation and design, including young Earth, but it gets into the gospel in the last chapter, and where he tells his testimony of how he came to Christ. So copies of this book are available on the book table at the end for just $10. In fact, most of the items there, DVDs and the books, are $10. There's one set of 3 DVDs that is $20, okay, because you get more than one DVD with that. Illustrious DVDs are beautiful productions, high quality, filled with great information. Any one of those that you take, you will enjoy. So I encourage you to get those and look them over. Okay, here are some pictures of me in action just to prove I was there. It's amazing what you can do with Photoshop these days. But, you know, pictures don't lie, but liars use Photoshop. That's how they say it, right? No, these are actual pictures of me and my team on the top right there, and some of the Big Sun servers and workstations that I worked on. And so it was a great thrill to be a part, but it had a bad ending, as you probably know. I was fired because I shared information on intelligent design with coworkers. And that's a no-no in a secular institution like JPL. I was trying to be low-key about it, but I shared one too many, and this lady turned me in for pushing religion and sharing my personal views. She watched Unlocking the Mystery of Life and just sped through it and decided it had a religious message that she didn't want to hear. So she goes to my boss and complains that she was harassed by this DVD. Now give it that I went to her cubicle and said, hey, would you be interested in watching this over the weekend? And I explained a little bit about how it talks about DNA in the cell, and she said, well, thank you, looks interesting. Does that sound like harassment? She accused me of harassment based on that incident. And it went to Human Resources.
You want a slide changer?
A slide changer?
Yeah.
Well, it's working here out of the laptop.
Do you need the laser pointer?
Well, let's see if it's bright enough. Some of these red ones aren't all that bright. Which button is it?
The big button.
Big button.
Yeah,
hard to
there
see.
We could say.
Okay, better than nothing. But thank you. So anyway, I was accused of harassing her. And with trumped up charges with Human Resources, I was given a written warning and I was eventually fired. Well, I thought that was unfair. I thought that's un-American because evolutionists get free rein to spew their propaganda. So anyway, I took them to court after I was fired and had help from the Alliance Defending Freedom, and you can read more about what happened. Basically, I lost based on the opinion of one judge who gave no reason for his decision. All right, but anyway, here's the film I often share, The Privileged Planet. Great film. You can find it on YouTube now and watch it for free. All right, my story was told in World Magazine and Creation Magazine in several places, and we talked about it on Bob's program a few years ago. The most complete account of what happened is probably in the 3rd edition of Jerry Bergman's Slaughter of the Dissident series, Censoring the Darwin Skeptics. So he gave a whole chapter to my story, about 40 pages in chapter 17, and if you want to hear more about what happened, it's described there. Anyway, before launch, I was excited to be at JPL and to be appointed to work as the system administrator on Cassini. I brought relatives like my mom and some of my nieces and nephews. They're all grown up now, but we got to see the spacecraft in the clean room there at JPL. My little niece there, Christy, is now in her 30s and a beautiful, charming woman that she is. So here's the spacecraft in the clean room being assembled. And you can see that round thing on the side. That looks like a flying saucer. It is. It flew to the surface of Titan. We're going to be talking about that. But a big machine loaded with instruments, loaded with packages. So let's learn a little about it.
When I first started working on Cassini, my daughter Jennifer had just started kindergarten. And now she's married with a daughter of her own. I've worked on the Cassini project for almost 30 years, and that's an entire Saturn orbit. Part of Cassini's success is really the tremendous international collaboration.
We had 3 space agencies contributing to this: NASA from the United States, ESA, the European Space Agency, and Aerospatiale Italian, the Italian Space Agency, all contributing hardware to this mission.
The beauty of Cassini is the design. It's the largest interplanetary spacecraft ever built. 12 different instruments brought from all over the United States and Europe. The Huygens probe, built by the European Space Agency. When you put all of that together, it's just a monumental machine.
So I knew those three people. The last lady, Julia Webster, was called on to testify in court against me, even though she didn't know me very well and didn't have any facts to support the issue of the case. But anyway, a fantastic crew of people. If we could have a little bit of light, I'm having trouble seeing with the buttons on my laptop. Okay. Anyway, Cassini by the numbers. I don't want to read all these numbers off to you, but just look at the right-hand column. 4.9 billion miles traveled since launch, and almost 4,000 scientific papers. This was as of a few years ago, and that's going to multiply into many thousands of science papers based on the data that Cassini returned. 294 orbits of Saturn completed, 453,000 pictures taken, 360 engine burns. It's amazing what this spaceship accomplished. And it's the most advanced, most successful outer planet mission ever launched, even including Voyager and Galileo. So a tremendous mission, a great honor to be a part of it. And I had a lot of fun. I was there for about 2/3 of the entire mission. It launched in 1997, and I was there up until 2011. Here I can highlight the portion that I got to work on before I was fired. It continued on for another 6 years or so before it ended by plunging into Saturn. Here I am by some of the photographs posted on the JPL walls. A great honor to be there. Here's one of the Sun servers that I had to administrate with a team of 5. And I was really into the mission. As you can see, me and Dave Duty there, who is one of the Cassini aces, we both had white Saturn cars with license plates saying it's been 2 Saturns, so that was fun. I spoke to astronomy groups, the Orange County astronomers, other groups, and would tell them about the mission, and it was always a big hit hearing about it. I didn't bring any creation or intelligent design or religion at all into these talks. They were just secular talks, but I enjoyed sharing the mission with groups. I led tours on lab schools would bring busloads of students, and I would take them around and show them the things. So I was really into it. I was not wearing a target on my back saying, I'm a creationist, shoot me, or anything like that. I was just trying to be a good worker and a team player. In Cassini is a big mission. Here are some 300 people that were involved at launch and even more at the arrival. If you're wondering where I am, let me help you out a little bit. So, yeah, I was in the group pictures, but the final group picture that they took in 2017 was called All Plus Alumni in 2017, and I am not in this picture because I became persona non grata at the lab, so I was not invited to be part of this picture. Anyway, Cassini and Huygens, the two missions, are named after astronomers. Cassini, Jean-Dominique Cassini, was an Italian astronomer who came to France, and he was the discoverer of the Cassini division in the rings and 4 of the moons, Iapetus, Rhea, Dione, and Tethys. Whereas Christian Huygens, a Protestant who was a believer as far as I know, was an important early physicist, and he discovered Titan, the large moon of Saturn. Here's the size of Cassini compared to a school bus, so you can see this was a big, heavy machine. And it was launched on a Titan 4B rocket there. It's up there inside the fairing on the top of the rocket. On the right side, I'm not going to list all the instrument packages that were on this, but it was loaded for bear for looking at Saturn through visible, infrared, ultraviolet, radio waves, you name it, it had it, to examine the science of Saturn. The 7-year cruise, it took 7 years to get there. Why? Because we had to take a roundabout route. You can't fly directly to Saturn, obviously. You have to take an enormous amount of fuel, plus everything's in motion, everything's moving. So what we did was we looped around Venus twice, and then the Earth, and then Jupiter, and we got gravity assist every time we flew by one of the other planets. But there was a long time from the time of launch to the time we got there. So we had fun. I was part of a singing group called the Cassini Virtual Singers, and we would make up songs with Cassini words to sing at special occasions and parties and stuff. So here we are in one occasion. Do we have sound?
As wings we go, the engine burns to guide our turns through dust and plasma flows. Slingshot past Jupiter, surfing craft will wink and wave hello, and sled the probe through everything snow. As Saturn bound we go.
Now in those early days, yeah, we were always quite a hit there. In those early days, we used just transparencies, but we got better as we went. So here are some of the buttons and posters of the flybys of Earth, and other times we flew by Jupiter, got some nice time-lapse footage of the cloud bands that you can see here, including the great red spot. So this was a good test of the cameras and the instruments as we flew by Jupiter in December 2000. The first moon encounter we passed was Phoebe, a little rocky moon way out on the periphery of the Saturn system. It's the outermost moon, and it goes in a retrograde orbit. So all the other moons are going prograde, but Phoebe is way out here going retrograde, going the wrong direction. And it even creates its own ring around Saturn, a retrograde ring way out there. But this was a good test of our cameras, and so we got real close to it. I'll be showing this map from time to time just to compare the various moons of Saturn with the United States, as you can see there. So Phoebe is a little one about the size of Florida, but there's other ones bigger, and Titan, the big yellow circle, would encompass the whole United States. All right, so here we are. There I am watching some of the pictures coming in. Here's Robert Mitchell, the NASA administrator, Ted Stevens, senator from Alaska, and various people, and watching the first images of Phoebe come in, and boy, were they great. Really sharp images. You can even see this landslide that exposed water ice underneath the dust on Phoebe. We believe some of the dust from Phoebe escaped the moon and landed on Iapetus. I'll be showing that a little bit later. So here we are watching the first images come in. I'm behind Linda Spilker, who you saw speaking earlier. And among the first to see new pictures coming in, that was really exciting. Here's a crater that's 8 miles across, and you can even see boulders at the bottom of this crater. Here I am standing by one of them to, just show their size. Are you awake? Are you listening? All right, I'm just checking here. Don't want to lose anybody. Here's mission control, fun, like in the movies, you see. And we finally got to Saturn, and we had to make a critical burn. The main engine had to fire after 7 years of inactivity, had to fire for about 40 minutes to slow down the craft so it would be captured by Saturn's gravity. So they had this all planned out in advance, and we were at Pasadena City College Auditorium watching to see if the burn was successful, and everybody erupted in applause after the burn was successful, and we knew we had a mission. So the Cassini Virtual Singers sang again, and now we had PowerPoint, and we had tracks that I put together in my music studio, so we were improving as we went. Anyway, here's the trajectory of the burn. The red line there is the burn itself, and it flew right over the rings and gave us beautiful pictures coming in. So this was Saturn orbit insertion, January 30th, 2004, and there's the artwork of the engine burning. So great success. Everybody's clapping there at the mission control and in the auditorium in Pasadena City College. So the singers got together. Here's how we improved. I was running the songs. Most wonderful time of the tour. So we were a big hit. We took a little fun with the Martians. The Martians get excited about their missions, but the Saturnians, we get excited too. So we had four main objectives of the mission: to study Saturn itself, including its magnetic field and atmosphere, the rings, the moons. There's about 62 moons of Saturn, just about 7 primary ones, and then Titan is the big moon, very exciting moon that we're going to be talking about shortly. Uncovering the mysteries of its rings, atmosphere, and moon system, and capturing some of the most stunning images.
We turned the Cassini cameras down to look at the rings, revealing them in a way we had never seen them before. I remember coming back to JPL early in the morning just so I could be there and watch those pictures one by one come down. And I felt like I could almost reach out and touch the rings that were right there.
It's a shadow of a moon across the rings. Well, I came in also to watch
Basically tried to carry in our toolbox everything you could think of to explore the Saturn system.
I came in early in the morning that morning too to look at the first images coming in, and it was exciting to be there with the JPL director, several scientists, and we're looking at these fresh raw images coming in, unprocessed but amazing structure we were noticing already. And look at these amazing waves. Bending waves are transverse waves that go up and down based on the influence of moons, and spiral density waves move in the opposite direction. They're longitudinal waves, and sometimes they collide in the middle and cancel each other out. In front lighting, like we normally see from the Earth in the top left, you can see that the B ring, the bright wide one, is very bright. But as you look on the shadowed side of the rings, things reverse. Notice that the Cassini division, which is dark normally, becomes bright. It's like the dust on your windshield when sunlight's coming through and you get the transmitted light. And look how dark the B ring is, because it's very thick with particles, so it doesn't transmit much light. But we found all kinds of amazing, like scalloped edges on some of these gaps and rings within gaps. I remember when Voyager went by and found that there were more than just 4 rings. There were hundreds of ringlets and gaplets. It was exciting. So we got to study those very close up. Now here's many times I was the only one taking pictures of, I thought, historic moments. And here is Dr. Larry Esposito of the University of Colorado. I helped administer his computer at the university from a distance. Anyway, he had discovered the F ring. of Saturn, with that thin outer ring outside the main rings, and 23 years earlier. So now here was his first look at Cassini's photo of the F ring, and you can tell he was very pleased and delighted with the detail he could see in his F ring. Prometheus is one of the shepherd moons of the F ring, and Pandora is the other one on the other side, and these two moons work in opposition to each other, pulling material away, but it concentrates material into a thin line at the center. There's actually several bands within the F ring. And Prometheus has an interesting story of interest to creationists. In The Privileged Planet, Dr. Guillermo Gonzalez did a study on all the places in the solar system that could have a total solar eclipse, where you could see the corona and detail. You would have to be on this line to qualify to get a total eclipse. And the Earth obviously has them, but the only other body he found that has the potential for a total solar eclipse was Prometheus. So if you were floating in a gondola in Saturn's cloud tops, excuse me, and looked at the right time at Prometheus at the sun, it would possibly create a total solar eclipse for about a half a second. You know, not quite as good as ours. But then Cassini got there and found out that Prometheus is potato-shaped, so it never would really cover the sun. So the only body in our solar system that has the beauty of a total solar eclipse, with all the design and all the coincidental alignment and the potential for science, is the Earth, that has intelligent observers that can appreciate and learn from it. I think that's phenomenal. So here's Prometheus, and you can see every time it goes around, it pulls more material around, and it creates, and those elongate over time, so it creates beautiful patterns. Now I want to show you how thin the rings are. We're going to see a ring plane crossing movie, and we're going to see the sunlit side and then the shadowed side, and watch how thin the rings are as we cross. You're going to be seeing moons go around, but the broad B ring there is very bright. Watch it turn dark afterwards, but notice how thin and how quickly it goes by right at the moment of crossing. All right, here we go. Ready? Boom. You know, they say that if you had a sheet of paper on a football field, that would be similar to the difference between the thickness of the rings and their breadth. So very thin. Gravity pulls all these things into the equatorial plane. But beautiful detail in the rings. We added color with ultraviolet, infrared, and visible light in 3 color bands. And so with different kinds of light, you can determine properties of the rings, such as their composition, particle sizes, and many other things. And in fact, radio occultation, where you look at a star beyond the rings as the spacecraft moves and record the light levels as it moves through the rings, gives you a great deal of detail. And so you can see, compared with visible light at the top of this slice, how a lot more detail shows up with radio occultation. So that's how multiple instruments can add to our knowledge. There's the A ring, the B ring. Notice the sharp edges, very beautiful. We started seeing the spokes that you may have heard about that Voyager saw back in 1981. These are cross-cutting phenomena that are radial across the rings, which shouldn't exist, but they did, and there was a lot of discussion back in Voyager days. We didn't see those spokes until about 3 years into the mission after arrival. It depends on the angle of light it's hitting, and we were approaching from one solstice through the equinox, where the rings are edge on down to the solstice on the northern side of Saturn. So here are some spoke images, and here's a beautiful side image of the rings with the shadow running across the rings. This is a view we can't get from the Earth, so very beautiful. All right, let's take a look at the largest moon, Titan. And this is fascinating. It was a primary target for Cassini and for the Huygens probe, which we'll talk about shortly. Titan is a huge body. It's bigger than the planet Mercury. And it's just a little bit smaller than Mars. So you would think of this as a planet in its own right, except it's a moon because it orbits another planet. But there's the Earth and Venus, Mars, Ganymede. Ganymede is the biggest moon in the solar system at Jupiter, but Titan is number 2, and it's a big number 2. Okay, Titan is the only moon in the solar system with a substantial atmosphere. And this is why Voyager, when it got there, couldn't see the ground, because Titan has smog. It has a thick haze made of methane and other hydrocarbons that blocks our views of the surface. But with Cassini's instruments, we could see through the haze, and we could travel down with a flying saucer to the surface for the first time. So we got our first good look at Titan right after entering orbit at Saturn. And here I was, again, the only person with a camera in the room taking pictures of this historic moment where we were getting our first views of Titan. A few months later, we got more. And now we're starting to see features on the surface and clouds at the South Pole. We could tell there were clouds because they moved around. So Titan actually has a weather system. And with infrared mapping, we had two infrared instruments, the virtual and infrared mapping spectrometer and the composite infrared spectrometer. And these were able to see through the haze and detect surface features. Also, with the ion and neutral mass spectrometer, we were able to detect molecules in the atmosphere, such as benzene and acetylene, ethane, nitrogen, methane. Nitrogen is the primary component. Methane is the second most important. We'll be talking about that shortly because that's an important story there. But Titan spends up to 20% of its time outside of Saturn's magnetosphere. So it's exposed to the solar wind 20% of its lifetime. And the solar wind erodes the upper layers of atmospheric methane. So could this last for billions of years, like secular scientists believe? That's the question we want to ask. The Cassini radar could also see through the haze by bouncing radio waves off the surface and mapping elevations and features on the surface. Here's an example of a radar image. And what are we looking at? Well, the bright areas are rough and the dark areas are smooth. So this gives you some picture of what you're looking at. And they began wondering, what are we looking at here? Are we seeing fluid flowing across the surface? Are we seeing wind streaks? Is there evidence of volcanism going on the surface? Cryovolcanism, which is ice volcanism rather than lava. We also found that the surface is remarkably flat. Most of the surface only rises or falls about 300 feet total. There are a few mountains that go a few thousand feet, but most of Titan is very, very smooth, and very few craters as well. We saw the weather changing over a period of months. Here's one of the largest craters we found. They call Circus Maximus. It's almost 300 miles across. And what's interesting is that there are streaks flowing into it, which they believe are fluid flow channels. And we believe we found evidence for cloud bursts of liquid methane in the methane clouds that flowed down and were able to erode channels at certain times. Here's a classic young impact crater with the impact debris field around it. And here's where its position is in the image of Titan that we got before the Huygens probe. It's right there, as you can see. So very few craters, which is remarkable for such a gravity-rich moon. It should attract a lot of impactors, but it had very few. Another surprise was that Titan has sand dunes. At first they wondered, what are these things? They look like cat scratches, that's what they called them at first. But they discovered that these are longitudinal dunes like those in the Namib Desert of Africa. And the dunes are 2 miles apart from crest to crest, 100 to 300 feet high, and they girdle most of the equatorial region of Titan, excuse me. Hundreds of miles long. You can see they actually wrap around high areas. So surprising to find sand dunes. The sand is made of ice particles with some organic chemicals on the ice particles. Titan also has lakes. These are primarily confined to the North Pole and the South Pole. Here's lakes and seas. The one of them they call Lake Superior is about comparable in size to Lake Superior on Earth. And they believe there is more oil because of the hydrocarbons on Titan than there are in all the oil deposits of Earth. Pretty surprising. Now the price tag of getting it here, how many dollars per gallon would that be at? But here's a radar map of some of the lakes at Titan's northern hemisphere. And they were able to see changes occurring over the months and years in the shorelines of these lakes. The south pole of Titan has Lake Ontario, and they could see deltas and evaporation occurring. So more images of Titan as we use the infrared and radar mapping. We learned a great deal about Titan. Then we had the Huygens probe ready. Occurred in 2004 was the target date, but it didn't actually arrive till 2005 because they had to make a course correction. But here's the flying saucer there, the Huygens probe, and you can see compared to the size of some of the engineers there, had a big heat shield and a lot of instruments. There's the actual probe that parachuted to the surface inside. And without reading all the text here, you can see it had 5 major science packages to study the molecules in the atmosphere, the winds, and when it landed on the surface to explore what the surface properties were like. And they actually designed it to float because they believed that Titan could be covered with a global ocean of liquid methane and ethane. Here's Jean-Pierre Le Breton. Again, I'm the only one taking a picture of this, but he was the chief scientist for the Huygens probe, and here he's describing the mission. I remember thinking, boy, this is going to take a lot of luck to work. This guy worked 23 years on a mission that would last just 3 hours. That's a big investment of your lifetime. So anyway, the probe release occurred on Christmas Eve 2004 after they had to redesign the orbit because the original plan didn't account for Doppler shift. And so the spacecraft and the probe were going to be lined up and they didn't account for that. And it was going to take the radio signal out of the transmission channel. So they redesigned with another orbit around Saturn so that they could launch it and it would go perpendicular to the mothership and eliminate the Doppler problem. That was a great feat of engineering. Otherwise, the mission would have been totally lost. So here's Christmas Eve 2004, Christmas time. We're all wearing our Santa hats and looking forward to this exciting mission. So here's artwork of the probe going. Now down here are actual images after the spring-loaded bolts exploded and the probe was on its way. When it hit the upper atmosphere, it heated up, so the heat shield took on a real brunt of, at Mach 2, it rose to 21,000 degrees Fahrenheit. That's over twice the temperature of the outer layer of the sun. So tremendous heat it had to be designed for, and then parachutes opened and it floated down to the surface over about 2.5 hours. Parachutes deployed, first one to slow it down and then another one to carry it all the way to the surface. But nobody knew what to expect. There was a lot of mystery about Titan's surface. A light was designed to turn on close to the surface so they could check the reflectivity of the surface. But they designed it actually to float because they thought that liquid methane and ethane were drifting down to the surface. So what would we find? Would it splash or splat or thud? Now I was betting on thud, but most of the scientists early on thought that there was a lot of liquid down there. An alien surface never before seen. So would there be lakes or even a global ocean of methane? Now look at what one of the chief Titan scientists said before. He said, one can calculate how much ethane has been produced on Titan over the entire history of the solar system. You see, methane will ionize under the solar wind, and the two ions will join together into ethane, C2H6, which is a liquid at Titan's temperatures and should just precipitate on the ground and collect over billions of years. He goes on to say, the result is that this remarkable moon could be covered by a global ocean of ethane with an average depth of up to several kilometers. You know, like a mile thick. This was said in 1999. And other scientists agreed with that, so they designed the probe to float. And much of the artwork showed big lakes or oceans, but nobody really knew until we got down there. The night before probe descent, we were at the Pasadena Hilton. I had some of my relatives there, and we heard Star Trek character and NASA people, John Rhys Davies of Lord of the Rings, Bill Nye, the science guy, were all there on a panel, but everyone was afraid to speculate what they might find the next day. And the big day arrived, January 14th, 2005. The European scientists are all excited on pins and needles waiting for the signal. Of course, the signals have to travel an hour and a half from Saturn, almost 1 billion miles to reach the Earth. And now the real Titan, and I want to play you this audio here of the radar echoes off the surface as the probe is descending. And as they get closer together, the pitch goes up. So let's hear the landing. We're getting closer. We hit something. What's down there? Well, on the way down, the cameras were recording remarkable things. After they got below the haze, about 45 miles up, they started seeing landforms like banks of cliffs and lake floodplains. This looks almost like the coast of California. You have river channels flowing down. So liquid methane and ethane must be flowing down these channels. And here's where the landing site looks from orbit. And here was our first view of the surface that the cameras recorded. Are you ready? No, not ready. Are you awake? All right. So let's watch the landing here. These are actual images, as we'll see. The European Huygens probe rode piggyback to Saturn. Here's the release. Huygens' mission to explore Saturn's hazy moon Titan. We can turn the sound down a little bit so I can read the captions. On January 14th, Huygens descended to the surface. Here's the re-entry with the heat shield, and now actual images coming down through the haze. 2.5-hour descent. We're starting to see these landforms. Titan's dense haze began to clear about 45 miles above the surface, revealing bright highlands of rugged ice and dark lowlands resembling a dry lake bed. See the river channels there? That was amazing. Scientists were astonished to see dark branching drainage channels, just like rivers on Earth, indicating that rushing rivers of methane had flowed on the surface. This is really historic watching this. They had thought Titan might have a global ocean of liquid hydrocarbons. So Huygens was designed to float. Getting closer now. Cassini later showed us that large lakes and seas are confined to the poles. Coming in for a landing. Here we go. There's the landing point, that little dot. And now, watch the shadow. It came to rest in a dark floodplain amid rounded rocks of water ice. And now see the shadow of the parachute coming down? These were actually captured by the cameras and put into this video. Here's a recreation of how it might have looked from above. It represents a major milestone in the exploration of the solar system. So it landed with a thud. No other spacecraft has landed farther from the sun. That was a great thrill to watch that happen. So the first actual view from the surface then with the cameras, they colorized it with Titan's natural colors. And to compare, here you see the sizes of some of the boulders. Basically, they're about football size. And notice they have rounded edges, which means they tumbled down these river channels and were rounded on the way down, like we see pebbles in river channels on the Earth. Compared to the Apollo landscape, here you can see the horizon on Titan and horizon on the Moon for comparison. But where was the missing methane and ethane? Dr. Jonathan Lunine had predicted, a global ocean of methane and ethane. Now I, being a young Earth creationist, predicted very little. So let's see who was right. He says, since this chemistry is irreversible, we can say that products, like ethane, are being made and deposited on the surface. If the chemistry on Titan has gone on in steady state over the age of the solar system, then we would predict that a layer of ethane 300 to 600 meters thick should be deposited on the surface. How much was found? Zilch. That's a scientific term meaning very little. They found moisturized vapor coming up from the heat of the probe as it landed, but really very little except in these occasional cloudbursts that would float down the river channels. Another exciting thing was that the atmosphere itself is very tenuous and should not last for billions of years. The methane acts like a space blanket, I was told by Dr. Sushila Atreya, who was the principal scientist of the Galileo probe that went into Jupiter, you remember? And he was now a scientist on the Titan probe. He said the space blanket protects the nitrogen from freezing out, but when the methane is gone, the space blanket is gone, the nitrogen will go from vapor to solid, and it will collapse to the surface catastrophically. That would be something to watch. That would ruin your day if you're on the surface looking at the sky. Well, he gave an upper limit of 100 million years for the lifetime of Titan's atmosphere. Very interesting. Now, 100 million years sounds like a lot of time, right? I need a stagehand here, so Rob, come on up here. I want to show you what this means by comparison. Let me get the right end here. All right, you take that end, and let's stretch this rope out across the whole stage here. This rope, if we can reach the full extent of it, is a timeline of the assumed age of the solar system. Okay, maybe go that way a little bit, and we'll try to stretch this out. So this is a 45-foot rope that represents the age of the solar system. And my question is, how much is 100 million years on this scale? It's 1 foot. 1 foot. So, I'm asking, what was going on the other 44 feet on this rope? You know? Why are we lucky to see Titan's atmosphere now while we're able to observe it? And you know, if that's 100 million years, how much is 10 million? Well, it's 1/10 of that. How much is a million? 1/10 of that. You're getting down into just very, very small dimensions for thousands of years. Okay, thank you. You can roll that up for me. Okay. My stagehand. But anyway, that's an amazing thing. And that's not the only thing that has an upper limit that's that small. There are other things about Titan, the atmosphere and the ethane buildup, and these other things cannot last for billions of years. Well, anyway, just to share the insider view of some of the celebrations, we had a lot of parties and celebrations whenever we had a major milestone. We went to the Athenaeum at Caltech, you know, the holy ground where Einstein walked, and had parties there. I'm there with the JPL director and my SA team, all very proud to be part of history. Okay, Saturn has a lot of satellites, and there you see at the bottom the limb of Saturn, and you see Titan, and then the relative sizes of the other moons. Plus, the ring system extends far beyond what is visible through telescopes. How many of you have seen Saturn through a telescope with your eyes? Great. You know, it's been known since antiquity as a planet, the sixth planet, but the rings were only discovered by Galileo 400 years ago. Now, beyond the visible rings, which you see close to Saturn on the bottom, there's this broad sheet of a ring that's called the E ring. And there's an amazing story behind that ring. In the thickest part of the E ring is a little moon called Enceladus. Let's talk about Enceladus. Here are the moons of the solar system scaled appropriately. Here's the Earth, here's our moon, and Jupiter has 4 large Galilean satellites that Galileo discovered. Saturn has Titan, and another big one is out at Neptune, Triton, and that's another retrograde moon, which is quite fascinating. At the south pole of Saturn, there's this gigantic hurricane, and it's so big the Earth would fit right inside of it. So, what do we call that? Cat 1000 hurricane? That's a big one. And at the North Pole, there's this strange hexagon shape here. Notice it there. That was discovered by Voyager, and we got good pictures of it with Cassini. It's apparently some kind of standing wave phenomenon that is very stable over decades. We don't know if it could last a long time, but it's very interesting now. And it corresponds also with the aurora Here you see part of the hexagon there. It's loaded with storms inside and out, but it corresponds also with Saturn's aurora that it has. And so you see the aurora images right on top of the hexagon. So very interesting. Also, Saturn has a strong magnetosphere, but an interesting thing for us creationists too is that it contradicts theory about the origin of magnetospheres, because the theory of magnetic fields is that you have some difference between the spin axis and the magnetic axis, okay? And there's an angular difference between them, and that's what generates a dynamo and causes all kinds of turbulence that generates the magnetic field. But at Saturn, the spin axis and the magnetic axis are perfectly aligned within part of a degree. So that violates theory, and they have no answer. I've read the scientific papers, they don't know why. And it basically, I think, falsifies the theory, so there must be another explanation. Okay, let's take a look at Enceladus. It's about the size of the state of Iowa in diameter, maybe Arizona, if you like Arizona better. And it's an amazing moon. Let's look at it. This is Voyager's best images. It's here you see it compared to the British Isles. And here's Voyager's best view of Enceladus. They've discovered it's the brightest object in the solar system, and it has some craters that are cut in half by some kind of flowing material, and it looks like some of the craters are melting. One hemisphere of Enceladus is heavily cratered, the other hemisphere has very few craters. And there's not any kind of material that could lower the freezing point and cause it to be soft like that. There's no ammonia, no carbon dioxide to speak of. It's basically water ice that you're looking at. So we wondered, would we find ice geysers there? And there was always this theoretical thing. Would we find cryovolcanism of some kind that's putting out material that would blanket the craters and blanket the surface? Boy, what did we find? We were looking for plumes early on, but we didn't see any for sure. You're looking at Saturn shine here on this limb. That's the reflection of light off of Saturn onto the moon and back to the Earth. A little like we have Earth shine on our moon. So our first close flyby, our second one actually, in 2005, and I'm here with the scientific team watching with eagerness to see what we're going to see. And boy, the detail that Cassini captured was amazing. Look at all these lineaments and craters that look like melted ice cream, like they've just softened into the surface there. And you see lines cutting through the craters at different angles. Almost pure water ice, no ammonia, no carbon dioxide. How can the surface melt at all? Then we had an extreme close-up, and we found, oh, look at this, tiger stripes at the bottom. At the South Pole are these parallel cracks. They're big canyons at the South Pole, and those look really interesting. And then they found out, here's a closer view of them, right there aligned on the South Pole of Enceladus, they found that heat is coming out of those cracks. Now, not heat like that would make us feel warm, but warmer than the very, very cold temperature of the rest of the surface. So the heat was coming right out of those cracks. So those became prime targets to study closer. Minus 120 degrees Fahrenheit, that's not very hot, but that's a lot warmer than minus 300. Then we discovered the plumes. November 2005, we saw stuff shooting out of those cracks. Enceladus has geysers. Amazing. This was really exciting. The rate is coming out at 120 kilograms per second, and the speed is coming out at 400 meters per second. So very rapidly this stuff is shooting out, primarily water vapor and ice particles, but a little bit of silicate dust and other materials. When they first saw the heat, they expected about that much heat, but they actually observed that much heat coming out. It's 2.6 times the power output of all the hot springs of Yellowstone in this tiny little moon, Enceladus. So we got more plume images from a distance and close up. And we found out that Enceladus is the source of the E-ring. That big, broad ring outside the main rings is being fed by this little Arizona-sized moon. I asked you, can that be going on for billions of years? In fact, there was a huge outburst on the way in the Saturn orbit insertion that like doubled the amount of oxygen that they measured coming from the E-ring. And they figured that Enceladus had some big burst of activity at that moment. So Enceladus joins the active body club. The Earth has volcanoes, Io has volcanoes, Triton has nitrogen geysers, and Enceladus has cryovolcanoes. And Bob corrected me today saying that it's not these only four. He has a whole list. What do you call them? TESS.
Transient events of the solar system.
Transient events of the solar system. So it's all over, including on our moon. There are transient lunar phenomena. So the solar system is more active than it should be after billions of years. Look how small this moon is. There it is. This tiny little moon is putting out a whole ring around Saturn. I've read the papers on this. How can they get the energy to output this much material for billions of years? And they have no solid idea. They try to say tidal flexing, like when you flex a rubber ball and it heats up, that maybe gravitational interactions with other moons are making it tides that rise and fall and heat up the interior. But there's not enough, by about an order of magnitude, to keep that heat going. And you would think most of the material would be gone after such a long time. So it's the smallest of the known volcanic moons. There's Io and Triton and the Earth. So this little moon is an amazing evidence of young creation, I believe. Okay, here's a backlit mosaic, a famous picture. We could never see this from the Earth. We're behind Saturn, and the sun is on the other side, and it's shining through the rings and lighting them up like a chandelier. Isn't that beautiful? And here you see the E-ring. Let me brighten this up a little bit. So there's the E-ring outside, there's the F-ring and the main rings, D, C, B, A. The lettering doesn't make much sense, but you just memorize it. And here's little Enceladus putting out all that material to create a whole ring. That's really exciting. Now another exciting part of this photo is that little white dot there. Now what is that? That's you. That is the Earth from a billion miles away. And so, blowing it up, you know, a view of the Earth like we've never seen before. And you can even see the moon behind it. If you blow it up enough, it's fuzzy, but there's the Earth and the moon peeking out behind it. From behind Saturn looking through the rings. I think that's exciting. So that made a famous picture that was shown on magazine covers all over. Saturn as you've never seen it. They did another image like this. It's actually a composite of multiple images in 2013. And once again, you see the E-ring, very good, with Enceladus blowing out all this material. And you see the Earth and the Moon again. And on this occasion, they asked all the Earthlings to smile and wave at Saturn. Cassini took a selfie of us there. So there's the Earth on that 2013 images. Anyway, more study of these plumes of Enceladus found great detail. I'm going to fly through some images here. These are all on the web, but we got super close-ups of these cracks. And here's how it might look if you were standing on the surface watching this stuff shoot out of the ground. We flew by multiple times, taking incredibly high-res images, watching them come in. Very exciting. And look at this detail on these images. That's remarkable. That you could shoot these images and navigate this spacecraft so close to a tiny little moon and get images like this. Here you're looking right into one of these tiger stripe canyons. And more of them. Boy, I wish I could spend time on these, but you can find these online. And very excited to watch these discoveries come in. We as creationists, we're all excited about collecting data, aren't we? We love nature, we love collecting data. It's the interpretations sometimes that we have trouble with. But here you see the circles indicate where known geysers are erupting. They've counted about 100 places where stuff is erupting. So more images, more flybys. There were quite a few, I think about at least 14, maybe 20. They even flew through the plumes. Some of the trajectories went right through the output of these geysers so they could collect particles with the cosmic dust analyzer, which is like a mass spectrometer on the spacecraft, and that way they could determine that most of it was water, ice, with a few silicates and other things. No microbes, no bacteria, no amoebas. They always talk about, oh, there's water there, there must be life there. No. Here's looking down another crack, another one, and here's an artist's conception. If you're standing by the side, a lot of the snow is piling up on the edges, and some of it takes a ballistic path around Enceladus and lands and coats much of the moon. That's why it's so bright. More Plume images, so very exciting discovery, along with Titan. And this is another young Earth discovery here. You can't imagine these guys were going for 4.5 billion years. Or maybe they just started up recently and we're just lucky to see them happening while we're alive. No. No, these are indications of a young solar system. Beautiful images here. And here's one from quite a distance, and you can still see the plumes from quite a ways away. Dione, a lot of other exciting moons that we could talk about. I'm not going to focus on them. I want to jump to Hyperion real quick, which is another oblong object, and show you how it looked. Here's one image that we took from a distance, then we got real close, and here's Hyperion close up. Isn't that amazing? Looks like this part was smashed in by maybe a soft impact after other impacts were made. And there's dark material in the floors of the craters that might be dust from Phoebe and other outer moons. Iapetus is exciting. Iapetus is well known, and it was known since antiquity to vary in brightness significantly. Sometimes it was bright, sometimes it was dark. And then Voyager found that it had a bright side and a dark side. Here are Voyager's best images of Iapetus, so we wanted to look close up. It's way out there, so we only could visit it twice close up. The first time we were tens of thousands of miles away, and here's how it began to look on 2004. Huge craters, and we discovered this exciting phenomenon here. It's actually a mountain range that girdles the equator. Here you can see sort of feathered edges between the dark parts and the light parts, and we wanted to find out what creates that dichotomy between a very dark part and a very bright part. The bright part is brighter than snow, the dark part is as dark as charcoal. So what causes that? Here's that mountain range again. These mountains are 12 miles high. And they go right around the equator, about 3/4 of the way around the moon. Looks almost like a walnut or something, or like two parts of a sphere screwed together. A little bit, very, very peculiar. And some of those impact basins are huge. Here's one where you can see a landslide has occurred and spread material across the floor of this other crater. Let me give you some numbers. This crater is 75 miles across. That cliff is 9 miles high. Imagine standing at the edge of that cliff with a wingsuit on and taking a free fall down 9 miles. That would be pretty exciting. So what's the secret of the dark and light sides? Well, we were 77,000 miles away from those images. Let's take images from 932 miles away. You ready? Look at this. Okay, we're starting to come in closer, and we're seeing very distinct portions between the dark and bright sections. So in other words, this dust must be very thin, a thin layer of dust. They thought, well, maybe it was oozing out from the interior. Well, this blew that theory away. It's on the surface. It must be dust collected from Phoebe and other sources. Here's that mountain range, 12 miles high. You want to come in a little closer? How about this? And here you're seeing very distinct differences between the bright and the dark on a local scale. So the dust is quite shallow. It can be penetrated. On the light side, you see the dark stuff collecting. And what they think is happening is this. It's pretty interesting. The dark parts of Iapetus, where the dust is, tend to warm up a little more from the solar insolation. And so that causes the ice underneath to become active, and it starts hopping around. And the bright ice starts migrating to get to a cold spot where it can be at an equilibrium. And so you have this runaway migration of ice to the bright spots as the dark spots get darker over time. Again, I don't think that took billions of years. In fact, they say that this migration escape process is actually, some of it's being lost to space. And so you would think that a great volume of material would have been lost to space by over billions of years. So that's Iapetus, pretty exciting moon, and here you see the map being constructed with more detail as the images came in. Here's a global portrait of the dark and light sides of Iapetus, and while we were out there, we looked back at Saturn and took this really beautiful family portrait where you could see Saturn and 6 of its moons. Okay, now you get extra credit if you can name these moons here, or even see 6 of them, but I'll give you a little help of labeling for you. There we have Dione, Enceladus, Mimas, Rhea, Tethys, and Titan. That big giant moon looks pretty small from the orbit of Iapetus. There are ring moons, moons embedded within the rings. I'll just fly through this real quick, but amazing pictures. Here you see Daphnis, a little tiny moon inside the Keeler gap there, and it creates a scalloped edge as it travels. So they found moons embedded within the rings at equinox when the rings were edge on to the sun. We were able to see things that you couldn't normally see, including propellers, where you have little embedded moons that leave a trail on both sides because of the gravitational interaction. You know, the trailing side moves slower than the leading side. So exciting things. Half-mile across some of these little moons, and they cast shadows at equinox. In fact, at equinox we found that some of the particles loft up above the ring plane and cast shadows along the A ring. So pretty exciting to see physics in action in these ways. Some of these particles, they believe, were lofted up as high as almost 2 miles, 1.6 miles. Well, then equinox gave rise to solstice, and so summer was coming, and a great second extended mission was counted with more flybys of more moons, and Enceladus flybys, and Titan flybys, and all kinds of exciting stuff was discovered. Here I am with a poster. This is just showing that I was the longest lived system administrator in the Cassini program. All the others kind of came and went over time. And I was the team lead for 9 of the 14 years. That was a great honor. Here's part of my team one year with our server room. And here's some of the system administrators that were under the guidance of Cad Burgess, my group supervisor, a great guy. He even bought some of my DVDs, but he was forced to testify against me at trial by JPL, and I'm sure that really hurt a lot. But I got to see him one time after that and told him, look, I really didn't want you to have to be involved in this, but they made me, and so anyway. Pray for Cad, because I think he has a Christian son, I know, and he needs to come to the Lord. One of the last pictures of me at my desk, and then the second extended mission went on, and a great exciting finish was to dive through the rings. They changed the trajectory of Cassini to go high up over Saturn and dive between the rings and Saturn. There's a gap there between the D ring and Saturn, and so these were high dive orbits, very risky. They didn't know if it would survive. But on the last one, they dove it into Saturn. So the grand finale orbits, and here's the singer singing again to a track that I had written, and words that we had put together.
Well, the Cassini team considers
A little louder,
itself a
please.
family, a team that works together and plays together. And here is one example. The Cassini virtual singers, they have a knack for putting a Cassini spin on just about any show tune.
So that was a great day. Of course, I was not there. I was the missing man in the virtual singers, even though they were singing along to my track and some of the words I had written. And in my place was this lady here, my accuser, who accused me of harassing her by giving her a DVD on intelligent design. And she was the one that pushed the domino that caused all my troubles, that got me in trouble with my boss, with HR, and eventually with JPL's lawyers, and an internationally reported trial on intelligent design, which, as you know, the judge ruled against me with no explanation. and gave the entire victory to JPL at a great cost to me. In fact, an expert witness at the trial said that I probably lost about $860,000 in lost income and benefits because I was going to stay through the end of the mission and retire afterwards. And so this lady cost me a lot of money, you might say. You know, I don't blame her, I pray for her, and I'm sorry for her misguided views that saw intelligent design as some kind of threat to her. But you know, after the trial was over and after I had lost and I was battling cancer at the same time and my mother had Alzheimer's, it was a terrible year, but God was faithful, and I'm doing very well today and just grateful to God for all He has done. But I got this email from this lady's sister, out of the blue. Her sister is a Christian. And here's what she told me. It so encouraged me to find that the Lord had placed people in her path that Margaret no doubt complained only because she was affected by watching the video, and that scared her. And that our prayers for them are being heard. So thank you for sharing the truth with her. It was the right thing to do. And that is rarely rewarded on this side. She went on to say, I'm so sorry that you paid the cost that you did, but I am fully convinced that if you even brought one soul into the kingdom, you will never regret the cost. Pray for Margaret. She needs the Lord. She's very confused in her views. And I pray for my persecutors often and remember them and remember the good times and just know that they need the truth. Well, a few final images and then we'll close out. Some of the last images of the last month before Cassini died, images of Titan and the rings, just beautiful things. And now let's learn about the ending, the grand finale of Cassini. I think this could be
a lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
Now watch the launch, it is really beautiful.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have Clinton Tower. Its program is in.
Phoebe.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
The SOI burn attitude or pointing position. Light up the rockets.
The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system. For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
Well, that was just 2 years ago this month. We can have the lights back on now, if you please. And a really historic ending. And even though Cassini itself is in ashes as part of Saturn, all that data, all those pictures are here safely on Earth and will be studied for decades. So thank you very much. It was a pleasure and honor to be with you and to share my story.
Check. Is this on? No.
Nope.
Check. Well, thank you. That was a wonderful presentation. So let's open the floor now for questions and answers. And before we do that, I want to pass these baskets around. You're probably used to us passing baskets. So this time, let's try to do it in a way that everybody actually knows what's going on. So I'll put one basket that way, and when it gets to the end of the line, hand it to the person behind you. And I'll put the other one in this column and do the same thing over here. So. Okay.
All right. Well, thank you so much. And it's
I'm
up to
sorry.
you how long we go here.
Yeah, one other thing is, if you have a question, raise your hand. David will call on you, and I will run around and try to get the mic to you. So wait till you get to the mic before you ask your question, okay? Sorry.
All right, who has a question? Maybe I'll just remind you of the videos and the books back there to take one. I also have bookmarks. Those are free. The bookmark tells you about Creation Evolution Headlines, my website, where I report on science of interest to creationists almost every day. And my technique is to go to the scientific journals themselves. I don't rehash other creationist material, although I may refer to it. I go to Nature, Science, PNAS, all these other major journals and find amazing things that are of interest to us. So I hope you check it out. The address is simple, CREV, CR for creation, EV for evolution.info. Okay, we're starting to get some questions, so. I also want to tell you about Illustra Media, that they have a website called the John1010project.com with a lot of free video material of high quality, so check that out. Okay, first question.
With all of the information that's available now and the discoveries that have been made over the last number of years, why do the people there just resist where the evidence is leading them?
Well, you know, it's a strange thing why they maintain their beliefs in spite of the evidence. And I found some interesting patterns, like when they're proven wrong and falsified, they say, this is exciting. So they put a happy face on it, you know. We're excited at these amazing things that we're finding out that blew away our prediction. I think there's a big ideological component to it because materialism is wedded very closely to the old Earth, to the age of the universe, and to Darwinism. And those two things are very big props for a materialistic worldview religion. And so that's why you see the resistance, I believe. Another question? Got a young man here with a burning question, so.
What's it like at the Jet Propulsion Laboratory, and how small is Saturn's smallest moon?
Okay, good questions. What's it like at JPL? Well, it's an exciting place. It has a culture all of its own. Most of the people are friendly and nice. I had a lot of friends, and I didn't run into trouble very often. You know, I'd go to lectures on the origin of life and maybe ask an innocent question at the end and not reveal my position. But most people were good and friendly. There are just a few that are these hardcore anti-creationists who want to just destroy people who don't accept Darwinism. And unfortunately, I felt the wrath of that myself. But it's a wonderful place with they have a lot of celebrations and parties and beautiful buildings, and there's probably more PhDs per square inch than most places on the earth there. It's really a highly intelligent place. But there's a lot of ordinary people, secretaries, janitors, and everybody else. So it was a great thrill to work there for 14 years. Now, as far as the smallest moon of Saturn, well, you could call all of the ring particles moons, in a sense. There's just really no cutoff between what's a moon and what's a ring particle. Some of the ring particles are about softball size, some are house size, and there's all those embedded moons I showed you inside the rings and in the gaps in the rings. So they go all the way down, I guess, from Titan.
Amy Mainzer?
What's that?
Do you know astronomer Amy Mainzer?
An astronomer named
Amy Mainzer.
Amy Mainzer. Is she at JPL?
She visited a few times, and she's on a show on PBS Kids called...
PBS Kids, okay.
Yeah, it's called Ready, Jet, Go.
Okay. I don't know her. I don't know. I never met her. I don't know about that show. I would just caution you to remember that some science shows are great when they talk about discoveries and data. But always got to watch out for the worldview of materialism that underlies a lot of it. Like you saw in that last video, they're talking about Enceladus might have the conditions for life. See? So you got to filter that stuff out and just focus on the science. Okay, Miranda has a question.
Hello. Okay, I have a couple questions. The first one would be, like, how much did the Huygens mission explore Titan? Like, was it just the landing, or did it then, like, move across the moon, or what? Like...
It just landed. It was stuck where it went, and it lasted a few hours before the batteries wore out, and it's, 290 degrees below zero down there. So it's hard to design anything to last through that kind of cold. And of course, the spacecraft that was communicating with it went outside of the range beyond the limbs, so it couldn't communicate. So just a short mission, but recently approved was a new mission called Dragonfly, which is going to be like a little helicopter that can travel around through the atmosphere of Titan. So look forward in maybe the 2030s for a new mission to Titan. That'll be exciting.
My other question would be, how did JPL communicate with the Cassini mission? Because it's like, you kept saying stuff about like they had to change the orbit and stuff and reprogram it. Like how, how long did it take to communicate that with the Cassini thing, and like how did it work and that type of thing?
Yeah, great question about the communication, and it's done through what's called the Deep Space Network, which is a network of radio dishes around the Earth, and as the Earth rotates, there's one in America, one in Spain, and one in Australia. So there's always one pointed at the spacecraft, and it travels through radio waves where you can send digital signals, and you get ones and zeros that translate into code. And so all the pictures are transmitted as ones and zeros and recreated here on the Earth. And the man who designed the Deep Space Network is none other than Dr. Henry Richter, who co-authored that book that we have on sale back there. So he traveled to all the sites and discovered and communicated with Washington, D.C. about the plans. At first they were going to make it a combination military and NASA network, but they decided to keep those separate. So the Deep Space Network is an entirely peace-loving civilian technology, and it's really amazing that you can send radio signals that far. They're still communicating with Voyager out beyond the edge of the solar system now. The radio waves have such low energy that a snowflake falling to the ground has more energy than these radio waves. But these big dishes can concentrate that faint signal, and it's amazing how that works. Truly amazing. And the science planners who plan all these orbits and turns and stuff, those guys are just phenomenal. And they have to plan months in advance for every turn every signal, turning on every instrument at the right time. So it's really a human achievement of phenomenal intelligence and ability that we can all be proud of. Okay, a couple more questions, and Rob, I'll let you decide how long to go on this. I know we got to be out sometime.
Okay, well, we can go a little while longer if
All right.
people keep having questions.
Hello, I wonder if you've thought, or anyone's thought about any parallel between the geysers off the moon you described and the supersonic jets possibly associated with the catastrophic plate tectonics. It seems that's associated with heat, and this is heat. It's ice instead of water, but I wonder if there's some chance for sort of a connection to be drawn from that data.
I don't think so. I think the CPT theory was modeled only for the Earth, which we know has plate tectonics. I don't think there's any plate tectonics at all on Enceladus. Now there's cracks, and there might be pressure cracks and stuff like that, forming those lineations that go through the craters and stuff. But they believe there's a liquid ocean underneath the ice, hundreds of miles down, and that liquid is spurting out through some of the cracks. But why they're at the South Pole and how long that could go on is a huge mystery. Whenever they find water, they like to just say, oh, maybe there's life there. It's like a distraction from the real problems. Okay, good question.
I had a question about Enceladus. Is there any theory about that seam-like range of mountains that goes around the equator?
Oh, at Iapetus.
Iapetus,
That big mountain range?
Yes.
Yeah. There have been some theories. Some have said maybe Iapetus had a ring that collapsed and landed around the equator because it's at the equator. But there's problems. Every explanation that I've heard has problems. So that they thought maybe it was spinning real fast at its origin and it sort of oozed out at the equator. But you wouldn't expect such a sharp mountain range like that from that process. So I don't think anybody really knows.
Nobody came up with the idea of two hemispheres that were glued together.
I like that theory, yeah. Yeah, there were two hemispheres and they just glued together right there. That's what it looks like. Got to follow the evidence where it leads, right?
On the, you need to turn it back on. Yeah, turn it off. There,
On the moon with the heat cracks in it, what would be this? How big? First off, how big is that moon? You said, but I didn't catch.
Enceladus with the geysers.
Yes.
South Pole. It's about as wide across as Arizona, maybe 300 miles.
Okay.
Across, so pretty small.
And what could possibly be the source of the heat on something that small?
Yes, I've looked at the papers on that, and they keep trying to come back to tidal flexing, like the ball that you heat up by squeezing, that interactions with other moons are pulling and tugging on Enceladus, but there's not enough of that tidal heating to account for that. The same problem with Io at Jupiter, there's just not enough. I heard a scientist give a talk at JPL my first year there explaining about Io that we can't account for the heat to generate all these volcanoes. There's not enough by an order of magnitude, he said. So, big problems to solve, and I think creation scientists ought to dive in and provide answers and explanations for these observations. Did I answer your question enough, you think?
Yes, sir.
Okay.
Did you all hear that? He just said that creation scientists need to dive into these sorts of questions. And so we have a whole room full of creation scientists right here. So I'd encourage somebody to start thinking about that.
I just have a question. I'm curious about your experience with the Jet Propulsion Laboratory, and what would you say that you maybe learned from the experience, or would you have done something differently, or what would you say to scientists like yourself who have the same leanings, who are in the scientific community right now, based on your experience?
Yeah, that's a good question. I was blindsided by this experience because one thing that I didn't take into account was gossip. When I was sharing a DVD with a coworker, I thought we were just having a little one-on-one conversation. But the program manager who testified at trial said he knew I was passing out DVDs on intelligent design from general hallway conversation. And my boss and the program manager knew about this, even though I never, talked to them about it. And they thought I was pushing religion by doing that. So they were primed and ready to go after me once they had a harassment complaint. So you have to be very careful. I think it's an individual thing between you and the Lord and how safe you feel, but in some cases I would say it's better, like if you're trying to get a degree, to sort of lay low and not make waves until you get your degree and maybe get tenure, so that you can't be fired like Michael Behe. He's protected because he's got tenure. And in some cases it's best to do that, but the Lord may lead you to be more bold and open about your beliefs. And so I think that's an individual choice. Yeah, there are things I would do differently. I would try to be more accommodating, I think, to people and avoid all kinds of argumentation. I wasn't argumentative, but on a few occasions I would get into a discussion with somebody about intelligent design and evolution, and I might have gone a little too far in some of these discussions, even though I never got in trouble for those. But I did have one success. There was a scientist in the science planning department who was very reticent about any kind of religion. And when I offered him one of these DVDs, he kind of backed off. No, I'm not, if this is religious at all, I'm not interested. But I said, well, just watch it, you might enjoy it. And so he watched it, and he watched another one, and he said, these are really good. And I never heard this before, and they make a good case. And he actually was defending intelligent design to one of his coworkers later than that. So you never know. I hope I accomplished some good with my efforts there, but you got to be careful sometimes in our secular society. So do what the Lord leads you to do. Okay, one more.
I've got a question. One of the moons that you mentioned had a lot of craters on one side, but not on the other.
Enceladus.
Enceladus, right. That is also very, very similar to our moon and Mars and a few others. And I'm wondering which side those craters were. Were they facing the inner solar system or the outer, or what, do you remember?
There might be different processes involved in the different cases. In the case of Enceladus, it may be that the bright side is being coated with the snow coming out of the geysers that are closest to those vents on the south side, whereas the northern side is not as much affected. But there are still questions and mysteries to solve, and I would love to see theists and creationists get involved in answering these questions without assuming billions of years, because that's going to mislead you. All right, good questions. I appreciate your attentiveness. I know we went over a little bit in the talk, so I appreciate your hanging around. Nobody is obligated to stay any longer than they need to go.
Okay, well, we've got one more question lined up here, and so then I'll just go ahead and say this now. When we're done, we'll have Bill come up and say a closing prayer, and then the book table is in the back, which everybody knows about. David has all of his materials out there. Our book guy didn't show up, so.
Well, I'll just stand there.
Can you man the book table?
Yeah, I can do that.
Okay. So he will be back there to present the materials, and also if you have any one-on-one questions that you'd like to ask him, I'm sure he'd be glad to help out with that. So we'll take this one last question. And, and one other thing, we need to start leaving the building by 9:15 so that we can have the building completely closed up by 9:30.
You may have addressed this. I don't know if I've heard it or not. Is it on?
I think the battery's going bad on it.
Okay, you may have mentioned, did we ever get to the definition of where the rings came from? In the first place, you had the ring, one of them was coming from one of the moons. Were all the rings from moons?
The rings have moons embedded in them, but that doesn't necessarily mean that moons gave birth to the rings. And I think that there's opportunity for some theorizing and modeling from a creationist viewpoint about that. Did God create Saturn with rings? They're very beautiful. Perhaps they serve an aesthetic function. I don't know. But the evolutionists are the ones that have real problems because, number one, they can't be as old as claimed. And that's very convincing now to all of the ring specialists. I call them ring masters, like Jeff Cousy and Larry Esposito and some others. They are baffled by the origin of the rings. And so they come up with weird theories like, well, maybe there was this icy moon, Titan-sized moon that wandered in a little too close to Saturn, got inside the Rotation of it, and busted apart and became the rings. Well, you know, you can believe in miracles if you want, but that's a miracle of chance. It's a little hard to swallow. It's kind of like the origin of the moon by a Mars-sized impact. As Spike Pissaris has said many times, impacts are the go-to explanation for everything in the solar system. If they can't explain something, they bring in some magic impactor that creates the phenomenon. So that's the only way they can explain that there had to be some catastrophic event recently. But why did it happen so recently that we see the rings today? Aren't we lucky? You know, scientists are not supposed to believe in luck. And I heard some of these ringmasters say that it's philosophically makes them uneasy to think that we're living in some special time where we can observe these things.